Assalamu alaikum everyone. So what are isotopes? Today we are going to discuss isotopes and electronic configuration. So what are isotopes? Isotopes are basically atoms with the same number of protons but different number of neutrons. So same number of protons but different number of neutrons. You can also say that they have the same proton number but different nucleon number. Again, another way of saying this would be that you have the same atomic number but different atomic mass. Okay, so there's three ways of telling what an isotope is. Same proton, different neutron number. Same number of protons but different nucleon number, where nucleon is what? Nucleon is the number of protons plus neutrons. Then you can also say that it has the same number of same atomic number but different atomic mass. Now, how are isotopes different? They have the same chemical properties but different physical properties. Slightly is the keyword over here. Only slightly different properties. Why? Because you have the same number of protons, so the element is exactly the same, but because there's one more or one less neutron, that means that the mass is going to be slightly different and the physical properties are also going to be slightly different. So let's take an example. Let's take an example of potassium 39 and potassium 40. Same number of protons, 19 protons, 19 protons, but the number of neutrons is different. This right here has 20 neutrons, this right here has 21 neutrons. So one extra neutron will make that slightly more mass, and that will lead to a different set of physical or a slightly different set of physical properties. All right, I hope that made sense. So now we are going to discuss how different electrons are arranged in an atom. So I have all of this written in front of you. Why? As I said before, it's better to take notes and to write all of this down. Why? Because it stays in your muscle memory that way. Okay, so very important that you write all the text and you take notes as well. Okay, so electrons around the nucleus move in orbits and we call those orbits shells. Okay, the orbits around the nucleus are known as shells and they have maybe fixed number of electrons. Okay, I'm saying maybe. Why? Because in your A levels you are going to learn different. So again, as per our O level scores, we say that they have a fixed number of electrons but different fixed number of electrons. So the first shell can have a maximum of 2 electrons only. Now, maximum of 2 electrons, mean does it has 2 electrons always? No. It can hold, it has the capacity of maximum 2 electrons at a time. And then each of the other shell can hold a maximum of 8 electrons. So like I said, it does not have 8 electrons, but they can hold, or they have the capacity of maximum 8 electrons. Okay, so this right here is a diagram of the shells around the nucleus. The nucleus is supposed to be here in the middle, and then you have these shells. Now, how are these shells? So let's say, for example, you have this hydrogen. Hydrogen has exactly 1 electron. Now, where is that electron going to go? Is that electron going to go over here in the outermost, on the innermost? Let's discuss that. So when filling electrons, you need to remember that each electron will try to get as close as possible to the nucleus. So you have the nucleus over here. Each electron will try to go as close as possible. So the hydrogen, we discussed that hydrogen has only 1 electron, and that 1 electron is going to want to be in either one of these positions. It's not going to want to be in the last shell or even the second to last shell. Okay, so the innermost. So the electrons will try, if there's an empty space, so these right here are spaces, these right here are spaces, and if an empty space is available on as close to the nucleus, that's where the electron is, that's where you will find it. Okay, so like I said, when filling, the inner shell are always filled first and then the outer shell. Okay, and what you need to remember is that the shell furthest from the nucleus, so this shell right here, so we are talking about the outermost shell. This shell is known as the valence shell. Or what is it known as? It's called the valence shell. And the electrons, again, I've put boxes around the electrons in the valence shell. These are known as what? These are known as valence electrons. Okay, so what did we discuss so far? We discussed that isotopes, different neutrons, same number of protons. What's electronic configuration? Shells. The first one can hold a maximum of 2. Each one after that can hold a maximum of 8. And then you have the outermost one, which is known as the valence shell, with electrons called the valence electrons. Now, why is the valence shell important? Why do we name this one differently compared to the others? That's because the valence shell determines the chemical properties of an element. Okay, so the chemical properties depends on whether you have 1, 2, 3, 4, 5, 6, 7 or 8 number of valence electrons. So let's say, for example, you have a bunch of elements. Let's say, for example, you have lithium, sodium and potassium. They have exactly one valence electron in their outer shell, so their chemical properties is going to be similar. Then likewise, you have beryllium, you have magnesium and you have calcium. Each has exactly 2 electrons in the outer shell. Their properties are going to be different from sodium, lithium and potassium, but the properties are going to be similar to each other. Okay, then maybe you have fluorine, you have chlorine and you have bromine. They each have 7 electrons in the outer shell. So the properties of bromine, fluorine and chlorine are going to be similar, but they are going to be very different from calcium, magnesium and beryllium, or maybe sodium, potassium and lithium. Why? Because the number of outer shell electrons differ. Now, how do we know how many electrons, how many outer shell electrons are there going to be? How do we determine where exactly each electron is going to land, or where do we place it? Again, we are going to talk about that when we discuss electronic configuration in much more detail in the next video, inshallah. Okay, so that's it for today. Pars out.